It's Tim B from International Academic School in Dubai. Today we're going to connect algebra to number theory through Pascal's triangle. How Pascal triangle is organized? First, it's organized into rows that start from row 0, that has only one term, which is 1. So how to organize it through the whole rows? We will first add zeros beside the 1. Then add 0 plus 1, then 0 plus 1, 1 plus 0. Put the result of this addition just below the two numbers, which is 1 and 1. Then again, in row 1, we will add zeros and add it. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 0 is 1. And so on, doing such additions. The first question says, find row 8, 9, and 10. Here we're having the 7th row, so you just can continue adding 1 plus 7, then 7 plus 21, and so on, and just put the answer over here. So it's 1, 8, 28, 56, this is the 8th row. Then we continue. 1 plus 0, just imagine the 0 over here. It's 1, then 9, 36. Keep on adding. The same steps will go for the 10th row. And we're done. The second question says, what's the relationship between row number and number of term in each row? So here, as I explained before, the relationship is the n plus 1. So if the number of row is 2, we just add 1 to this number and we'll have the number of terms. For example, we'll add 1. So 2 plus 1, it's 1, 2, 3 terms in row 2. The second question says, what is the relationship between the row number and the second term in each row? And as I explained previously, we took the terms of each row by adding the previous row. So we had the second term in row 3, 3. As a result of the addition in the previous row, which was 1 plus 2, and we had the result 3. The fourth question says expand x plus 1 and x plus 1. It means twice. So we will use the both ways, the Pascal's triangle way and the normal way that we use as distributive property. So first we're going to expand x plus 1 by x plus 1. So we use the distributive property. So x squared plus x and plus 1. You will simplify it by adding the like terms. This is the normal way we do it. Now we're going to use the Pascal's triangle way by adding this exponent over here. So we'll just do it as this. X into 1 plus x Here we added just one more term over here. If they gave us 2 as an exponent, we'll just expand it into 3 terms over here. Then we'll just take this exponent and start to add it over here. 2 into the decreasing order, 1 and 0. So this will be cancelled. Then we'll start by 0 and cancel it into the increasing order. And so we'll just take the coefficients from the Pascal's triangle. So at the second row, we're having 1, 2, and 1. So we'll just take them and add them over here. Then we will multiply 1 by x squared, so it's x squared, plus 2x, which is multiplied by 1, plus 1. And you can see that at both ways we had the same final answer. But this way is much better, as it's shorter and more smarter. The fifth question is just the same as the previous one, but here we're going to expand it 3 times. So as we did, we'll use the same distributive property first. We multiply first those, and we'll get the same result. Then we should multiply this terms to this one, and we'll get we'll just simplify it by adding the like terms. And this is the final answer. Now we're going to use the Pascal's triangle way. So we'll just add. Okay, we'll just do as we did. x1 plus x1 then add the coefficients, which is 1, 3, 3, and 1. Add the powers, 3, 2, 1, and 0. So this is cancelled. 0, 1, 2, and 3. Then we shall multiply x3 plus 3x x squared plus 3x plus 1. So as we did again, the Pascal's way is much more better and an easier method for the higher exponent expansion. And thank you. Wish that our explanation was useful for you all.